Hi everyone, welcome again to my channel Code with B. We have already talked about the AES algorithm, different kind of rounds. So in each round we need a different key, right? So originally we have got a key of length 128 bits or 192 or 256 bits. For the 128 bits we have 10 rounds, so we need 11 keys. Similarly we need 13 keys for 192 bits, 15 keys for 256 bits. But originally we have got only one key, which is the initial key K0. This is the key, that is what we have got. From this key K0 we need to generate 10 more keys for 128 bits. For generating all those keys we have a technique called key expansion. So what we are doing, we are expanding the original key to the different keys. If I have to represent this key in a matrix form, so I can have a 4x4 matrix where each cell of this matrix represent one byte. If I have a matrix like this, okay, so this is representing the first byte 1, second byte, third byte, fourth byte, this representing the 16th byte. So this is our first word W0, W1, W2 and W3. The 16 bytes are represented using the 4 words. If we need 11 keys, that means we need 11 cross 4, that is 44 words. So using the key expansion we are going to generate the words from W0 to W43, that is 44 words. Whatever 4 words we have are representing the key 0, then the next subsequent 4 words will be K1. Similarly the last 4 words will be the K10. For the 192 bits key, instead of 4 words we will be picking the 6 word, and for the 256 bits we need 8 words. Whatever words we have W0, W1, W2, W3, from these words we need to generate W4, W5, W6 and W7. Similarly we can get the every subsequent 4 word from the previous 4 words. So we just need to understand how to generate these 4 words from the first 4 word, and the similar process will be applied for the all the words until we reach the 44 words, right? So for that there are a couple of steps involved. The first one is the rot word, which is basically the rotation. Second step is the substitution, and then the third step, which is round const. For generating the word 4 we need W3 and W0. In the first step we have W3, which is B13, B14, B15 and B16. In the rot word, what we will do is we will shift the bytes to the left by 1 byte, okay? That is B14 will come over here, B15, B16 and then the B13. So this is rot word. So we have got the W3, which is shifted by 1 byte. Assume that we have this W13, W14, W15, W16 is like this: 23, 64, 52 and 11. We will represent this W3 as 23, 64, 52 and 11. The rot word will shift these values to the left: 64, 52, 11 and 23. Then the second step is the subwords. Here we have to substitute all of these values from some lookup table. The way we have used the lookup table in our rounds, here as well the same matrix will be used. So we have a matrix of 16 cross 16 matrix, 0, 1, 2 up to 15. Similarly here it is. The same way the substitution would be like 8-bit data to the 8-bit data. So we will pick the 8-bit here, the 6th row and 4th column. 6th row here, suppose this is the 6th row, and then the 4th column, which would be somewhere here, and the value is 18. So now we are going to replace this 18, this 64 by the 18 value. So we have got 18 over here. Similarly this 52, 5th row and 2nd column, which is somewhere here, maybe here, and the 2nd column, so this value, okay? Suppose this value was 23. So we will replace the 23 over here, 1, 1, will be replaced by this value, which was say 32. So we have got 32 over here, and then 23, which is this, and 3 over here somewhere. So we will replace this by, this is 55, so we will replace the 55. Okay, so this is the subwords. Now the final thing is the round constant. So here we have round 1, R1, R2, R3, R4 up to R10 for the 128 bits. So every round has their fixed value. So for round 1, the value is 01, 02, 04, 08 and up to 36. So for every round we have a round key. For generating the K1 we have round 1, right? For the R1 we have a value 01, and we will be XORing this value with this word. So here we will be XORing this value 18 and 01. So we have 01, 00, 00, 00. This will be XORed over here. So after the XORing we will get our round const value. Eventually whatever value we have received over here, we will XOR this value with the W0 value to get the W4. So W4, this value is W0 XOR with this function which we have applied, which is basically the rot word. So we have got the rot word which is W3. Then we applied the subword over here. So whatever rot word we have received, we applied the subword on this. Eventually we applied the round const. Okay, so this is our W4. For getting the W5, we will be using the W1 and we will be XORing it with the W4. Similarly for W6, we have W2, we will XOR it with the W5. And for W7, we will use W3, XOR it with the W6. This is how we get our W4, W5, W6, W7. For generating the W8, W9, W10, W11, this will become our initial values, and then the same algorithm we will apply and we will get our next 4 words. Eventually we will get all of these 44 words. Same way we can get the 78 word for 13 keys and 96 word for the 15 keys. This is about the key expansion that is being used in the AES algorithm. I hope you enjoyed this video. In the next video we will come up with the implementation of AES algorithm. Till then, happy coding.